Okay, we're going to continue on talking about motion graphs. The previous video was about a position versus time graph. Remember, the slope represents velocity. Some people find motion graphs difficult, and there's probably various reasons for that, but one of the reasons is because there are two different graphs that we have to look at differently. And I think people have a hard time being able to switch back and forth between the two. If this was the only graph we had, I don't think people would have much of a problem. So what's about to happen is that you might have gotten used to thinking about the slope on this graph. Positive slope, positive velocity, negative slope, negative velocity, slope is 0, velocity is 0, etc. So now we need to kind of put that on a shelf, and we need to learn how to think about it a little bit differently, because in this graph, on a velocity versus time graph, we actually don't care about the slope basically at all. So let's look at this one. The slope of this graph does represent something. It's not velocity now. It's actually acceleration. I could take you through and prove that to you in the same way we did in the previous one, but I don't really want to do that because you're just not going to find very much information by looking at the slope of this one. With both of these graphs, the thing that unites them both is that you always want to pay attention to whatever represents velocity. So on a position time graph, the key is the slope, because the slope represents velocity. So we're going to look at slope here. On a velocity versus time graph, the thing that represents velocity is the y variable itself, the y value. So the key for analyzing a velocity versus time graph is the y value itself. Okay, so on a position time graph, we care about the slope, never the y value. On a velocity versus time, we care about the y value and basically never the slope. So it can be a little bit difficult to think about this. So try to forget about slope for a second, and let's just think about what we know about the y value. So everything that you can tell me about the y value of this graph is also true about the velocity. Just the same as this one. Everything you can tell me about the slope of this graph was also true about the velocity. So let's look at y value. So again, not using slope here. Whatever the y value is doing, that's what the velocity is doing. So for these two words are now interchangeable, just like slope and velocity were interchangeable before. So the y value is going to tell us three things, and it's the same three things that we could tell from the slope in the graph above. The y value can give us the direction of motion, and that is again whether the direction is positive or negative. But we're not looking at the slope. It doesn't matter whether it's a positive or negative slope. Slope doesn't matter here. It's about positive and negative y value. So if you look at your y numbers, positives are above the x-axis, negative y values are below the x-axis. So everything above the x-axis is moving in a positive direction. It doesn't matter whether it's a positive slope, negative slope, or zero slope. The slope doesn't matter. It's all about the y value. So everything above the x-axis is a positive y value, therefore has a positive velocity. That means positive direction. And everything below the x-axis has a negative y value and is therefore moving in a negative direction. We might say this is to the right and this is to the left. Okay, and it's difficult to make that transition because it's different from the way we thought about direction before. Slope doesn't matter here. In addition to the direction of motion, we can also, just like before, we can find the speed, which is just the number. That's the magnitude part of the velocity vector. But now it's easier. We don't have to calculate the slope like we did before. We had to calculate the slope. Here, slope doesn't matter. All we have to do is read the graph. And that's easy. So if we look at this graph, and I want you to get used to this, you will be given graphs like this. And the question could say, at 7.5 seconds, what is the velocity of this object? And all you have to do is read the graph to find that out. I'm going to find 7.5 seconds, which is right here. Look up to where the graph is. What is the y value? It's all about y value. What is the y value here? It's 25. The velocity is 25, positive 25 meters per second at 7.5 seconds. Could say, what's the velocity at 25 seconds? There's 25. The y value at this point is -10, so the velocity is -10 meters per second. So I can also find the actual speed. I can give you the velocity because I notice I just included the direction along with the speed. I gave you the whole vector. Third thing I can tell you is, just like before, if speed is constant or changing. So again, not based on the slope. It's not about whether the slope is constant or changing. So we're not looking at straight lines versus curved lines on this one. In fact, there will be no curved lines on these graphs, on velocity versus time graphs. It's all about the y value. If the speed is constant, the y value will be constant. And if the speed is changing, the y value will be changing. All of these are in terms of the y value. So constant y value is a straight horizontal line. So this is a constant y value, therefore it's a constant speed. 25 meters per second during this whole segment. This is a constant y value, so it's a constant speed. 25 meters per second, or -10 meters per second during that whole segment. But in all of these other portions, the y value is changing. It's increasing or it's decreasing. Therefore, the speed is changing. All right, so we can look at these two questions down here. They're the exact same two questions as we had above. How can we tell if the object is moving or going forward or backward? And guess what? They're going to be the same answers that we gave above, except instead of answering the question in terms of the slope, because slope is what we dealt with here, now we're going to answer the question in terms of the y value. How can we tell if the object is moving? Well, I know that the object is moving if the y value is anything else other than 0. So the y value is 0 on the x-axis. So with this particular graph, the only time that this object has ceased its motion, the only time that the velocity is 0, is when the y value is 0. That's on the x-axis. So that's this point and this point here. How can we tell if the object's going forward or backward? We talked about that already. That's based on whether the y value is positive or negative, and we did that here. Up above the x-axis, positive direction; below the x-axis, negative direction. So I want you to do something. I want you to label each segment of this graph as I'm doing here. You can go ahead and take a minute and do that. And then what I want you to do is I want you to think to yourself, this can be your own practice and you'll have to pause the video to do this, but with each of these segments, again, always based on the y value. Whatever the y value is doing, that's what the velocity is doing. Based on the y value, I want you to answer 2 questions about each of these segments. Number 1, I want you to be able to tell me what the direction of motion is, positive or negative. And I also want you to tell me whether the speed is increasing or decreasing or staying the same. So speeding up, slowing down, or have a constant speed. See if you can answer those 2 questions. Again, it's all about the y value, about these segments. So I'll start with the first one. If you look at the first one, I want to know about the direction. Well, I know that I can find the direction of motion based on positive or negative y value. Positive y values are up above. So all these are positive y values, so it's moving in a positive direction. So I'm going to write that right there. And then speed, is it increasing, decreasing, or staying the same? Well, this y value is increasing. It starts at 0, ends at 25. Therefore, the speed is also increasing. So this object is moving in a positive direction and speeding up. So I want you to do the same process with number 2 through number 8. Go ahead and pause the video and do that now. Okay, so if you thought about that, let's go through each of these and see if we can figure them out. Remember, everything above the x-axis is moving in a positive direction. So that means number 2, these y values are also positive. Number 3, they're also positive. Everything, this 1, 2, and 3, moving in a positive direction. Direction doesn't change. So positive direction, but what is the y value doing right here? What is happening to this speed? Is it speeding up, slowing down, or staying at a constant speed? Well, this y value is not changing, it's constant, so that's a constant speed. So positive direction, constant speed. This one, we already said, is positive direction. The y value goes from 25 down to 0. So the y value is decreasing here. Therefore, we're going to say that it's slowing down. So on the first three, it's positive direction the entire time. It doesn't change direction. Everything is above the x-axis. But here it's speeding up. Now it has a constant speed. And now it's slowing down. Number 4, it's not going in a positive or negative direction. It's not above or below the x-axis. The y value is 0. Therefore, the velocity is 0. It's stopped at number 4. Number 5 is where people typically get confused. And the reason is because when the object is moving in a negative direction on a velocity time graph, it can get confusing to think about what's going on. So many people say these words, right? I'll ask about what's going on at number 5, and people will say, they'll use the words going down, right? The graph is going down. Or they'll use the words, like if we look at number 1 or number 7, they'll say, well, it's going up. Okay, and so what they'll say about number 5 is they can agree that it's moving in a negative direction, but it's not moving in a negative direction because it's a negative slope. Slope doesn't matter here. It's moving in a negative direction because the y values are negative. They're below the x-axis. And then people will say, well, that's slowing down because the graph is going down. I want you to right now strike these words from your vocabulary. We don't need to use these, okay? Because number 5 is not actually slowing down. So if you think about the speedometer on your car. So here's your speedometer. If you think about it, it's not hard to understand. Regardless of what direction you're going, whether you're going in forward or reverse, positive or negative, let's say. If you're speeding up, your speedometer does this, meaning it goes away from 0. Your speedometer is moving away from 0. And when you're slowing down, regardless of your direction, forward or reverse, positive or negative, your speedometer goes towards 0. It approaches 0. Okay? So I want you to think about that when we look at this graph with velocity time. In number 1, I don't even want us to say that number 1 is quote-unquote going up. Let's not say that. Let's look at what the y value is doing. It's clearly going away from 0. Number 5, the y value is doing the same thing. It's going away from 0. It starts at 0 and it ends at negative 10. It's going away from 0. So since it's going away from 0, it's actually speeding up. So this is negative direction and the velocity is increasing. I should have put that up here. This one is increasing speed. This one is constant speed. This one is decreasing speed. This one is no motion. And then right here we have negative increasing speed. This is speeding up in reverse, we might say. Number 6, the direction of motion is also negative because below the x-axis, as is number 7. But the y value isn't changing at all. It's not going toward or away from 0, so the speed is constant. And in number 7, again, someone might say it's speeding up because it's quote-unquote going up. We don't want to use that term. The y value in number 7 is approaching 0. It's getting closer to 0, just like when you slow down on your speedometer. So the speed on number 7 is decreasing. It's slowing down. And then number 8, on the x-axis, so velocity is 0. So when we put the whole motion together, this might be a car going forward, and it speeds up and now moves at a constant speed and then slows down and stops. Now it's going to go in reverse, speed up because it's going away from 0, constant speed because of constant y value, slow down, all still in reverse, slow down because it's going towards 0, and then it will stop. That's your velocity versus time graph.